So let me park this thing here. All right, so I did Cinemachine with the projectile weapon and kind of glossed over how the different things worked with it, and I think I also used Cinemachine with the conveyor, but the Cinemachine is a tremendously powerful camera management package, and the documents are all available here. There are a ton of videos out there. I'm sure this is only the tip of the iceberg for what's out there about Cinemachine. A lot of Unity Unite not tutorials, but demos where they were blowing the horn for it back in 2017 when it first came into existence. The Cinemachine is from the package manager. I always recommend using a verified version. And having added Cinemachine, you'll see that there's now a new menu item. The menu item for Cinemachine has all the different types of cameras that you can just instantly create without having to think about anything. The way Cinemachine works is you have these virtual cameras. You can have as many of them as you want, and they attach to one of the actual cameras, and usually it's the main camera, a component called the cinema brain. And so like this little main camera here, it has the icon showing that it has a cinema brain, and the cinema brain is down here with some options that I haven't explored myself. I've just left things pretty much at the default. So the very simplest one is just to make a virtual camera, which is what I've done in this scene here. And it's the process of making the virtual camera, puts it in the world, and attaches a brain to the chosen camera. You can have non-brained cameras in the scene as well. So when we look at one of these virtual cameras, there are three basic tools that it's built around: the body, the aim, and the noise module. So the basic camera looks something like this. There's some stuff up here, including who you're going to follow and what you're going to look at. These are two different things. One is the object that the camera tracks around the world, and the other is the object in the world that the camera looks at. And it's kind of interesting that they give us access to both. Things like the lens setting. While our main camera may have certain field of view and near and far clipping planes, the virtual camera overrides that with particular settings that we can apply here. The different pieces, the body kind of controls the orientation of the camera. And there are a number of different choices. The easiest one is hard lock to target, in which case it just locks onto the target, looks directly at it. But there's a transposer, a framing transposer, orbital, track dolly, and do nothing, each of which have different options that produce different behavior. This is definitely a TMO. I think the choice that I'm using here is a transposer. And so here I'm binding with a lock to target. And we have various settings for the offset of the camera from the target. So I'm 3 above and -10 behind my character. And then we have various damping settings for how how smoothly the camera responds to the movement of its target. The aim controls how the camera tracks its target. And again, lots of options. The composer is probably one of the simpler ones, but of course there are other choices. We've got group composer, hard look at, point of view, and others. But so here we have access to a lot of different controls that moderate how the camera responds to the movement of its target and its attempt to keep in the position that's specified by the body. These colored things in the window here, when you have the camera, the virtual camera selected, and you have game window guide selected, shows you the various zones. And we have basically 3 zones. There's this kind of white area in the center, which is the dead zone width. And any movement inside that zone of our target, which is shown here by the little yellow dot, will not result in the camera moving. So let's see if I can do this. If I move my character, oops, I want to not maximize on play. If I move my character, whoops, didn't mean to do that, sorry. If I move my camera subtly enough, that spot will remain in that little zone. You can move the camera around, you can move the object around, and the camera won't respond to it. The blue is the soft zone. And the soft zone it'll allow the target spot to go into the soft zone, but it will want to move it back into the dead zone. And how rapidly it moves back in is based on the damping that you specify both for horizontal and vertical. I have a lot of damping here, and so that makes the soft zone very soft. And so when my character moves into it, it doesn't really hold it very well, and so but it does move it back into the little dead zone over time. If I set this down to 0, the soft zone now becomes hard, and it won't let me move my target out of that dead zone in the middle there. And of course, if we set this to something like 0.5 and 0.5, whoops, not 0.5, and now I have kind of it's softer. I mean, it's a little harder, a little more viscous, and it holds our character and moves them back with a certain amount of time. There's also look ahead. It can anticipate your movement and how smoothly you do that, and whether it ignores the look ahead. And we also can set the X and Y position of the center of my zone here. 0.5 is the middle of the screen, and I forget what bias is. But so this is the basic virtual camera. All the virtual cameras have this feature that the aiming allows you to bracket where you want your camera to be looking, and you can of course make this dead zone really small, in which case it kind of rigidly sticks to that character, although because it does go into the soft zone with that appropriate damping, things happen. One other thing that's different about the Cinemachine is that changes that you make during gameplay persist. And this is a setting up here somewhere, saved during play. So all those changes that I've made are now still here. They persist into the changes that I've made. And this is unlike every other inspector asset that we change during gameplay that is not persistent. So that's the basic camera, and it's pretty cool. Oh, and the noise, I'll show you an example with noise later, but the noise module is down here, and there's a bunch of pre-made noises, and you can define your own, of course. So all of this stuff. Okay, there's also a slot for extensions down here, and one of the extensions is a collider, so that you can deal with the issue of a camera that runs into a wall. So your camera can have a collider in it, so that as you turn your back on a wall, it adjusts its position so that you don't get clipped by the wall. And there's a really cool impulse listener that listens for impulses that you can make with bouncing objects and bombs and stuff like that, that will shake your camera in a realistic looking way. And it's an extensible class so that you can write your own if you figure out how that works. So that's the basic camera. The next one I'll show you, don't save. The next one I'll show you is the free look camera. And this is just generated by pulling down and saying, I want a free look camera, and it puts it in here. And the free look camera has follow and look at targets, and it has various settings for the axis control. The free look camera is kind of interesting in that it has 3 different rigs, a top rig, a middle rig, and a bottom rig. And these rigs are controlled by the position of the mouse in the window here. So as I start off here, I'm now in the bottom rig. And as I move the mouse up, it moves into the middle rig and then ultimately into the top rig. And as you can see, each of these different rigs can have different settings. So, you know, when I go into the top rig, it moves the center target all the way over to the left. And all of these things are adjustable in here. You can even have what it looks at overridden in the different rigs. So in my character here, they're all looking at the neck and following the third person, but in the rigs, you could change what it looks at. You could have the bottom rig look at its feet or something different. And here are all the different settings for each of the different rigs. The different rigs are controlled by the height and radius. So when I'm down here at the bottom, I'm at a height of 1 meter, and I'm 3 meters from the player. As I move this up, the height of the camera moves up to 3, and the radius pulls back to 5. And as I go up to the top rig, the height of the camera is now 5, and I've pulled back to a radius of 10. So it's all very cool. And this is an orbit camera so that you can orbit around your player, but as the player moves, it does follow the player. And I believe, well, no, it didn't adjust. There's settings to make it zip back, y-axis recentering, I believe, sets that back. TMO, lots of different options here. Pay no attention to these down here. I'm using a different setup here. So that's the free look camera. each one access controls, binding mode, simple follow with world up, but there are other binding modes that you can choose, each one with different options. The different, I believe they can have different lenses as well, so the different ones can have different lens settings. Now, the real power of Cinemachine comes in when you have several virtual cameras, and you can have virtual cameras of different types. So you can have just a plain virtual camera like we had on that first scene, and you can have a free look camera, and you can switch among them. I did that with the Archer, where all I did was adjust the camera's priority in scripting. When I wanted to change to the aim, I just boosted the priority of the aim camera. And when I wanted to go into the tunnel and be right behind the character, I just boosted its priority. And that was an easy way to do it. You can also set cameras active and inactive. With set active true or false. That's another way to do it. But Cinemachine also provides us with tools for managing several cameras, and there are a bunch of different ways of doing it. There's a blend list, there's state driven, which is really cool because it attaches to the mechanim state animation states, Clearshot that finds the best picture, and mixing that is adjusted from scripting. So with the blend list, don't save. Here's a blend list camera, and this camera has a whole bunch of virtual cameras that are placed around my character in different positions. And the blend list does it based on time. So it starts off with camera A, holds it for 3 seconds, and then blends to camera B over a period of 5 seconds, holding it for 6 seconds, which means it's going to stay on camera B after it gets there for another 1 second. And then it switches to each of these different cameras as time goes on, and ultimately comes back to camera A, where it then stays. So if I start this thing, I'm not doing anything. This is all being done by the blend. It held there on camera A for 3 seconds, moved to camera B over 5 seconds, moves to camera C, holds for a second, moves to camera D, and moves on to camera A, and then camera E, and each of these are just set around my player, and then it goes back to the original camera A. So clearly this is something you could use with a cutscene where you want to actually control the camera, and there's a whole bunch of control over in terms of how the different cuts go. You can just have an instant cut, or you can ease in, ease out, various different settings. Again, this is a TMO. I can't imagine more different options that you have to set in order to get things to do things. The mixing camera has weights. And so here I have my mixing camera has 2 virtual cameras. And each of these cameras can be simple cameras, or they can be free look cameras. The mixing is just going to mix among them based on their weights. And so, if I change the weight here, it's changing between all this camera, and I have to turn the weight way up in order to get all that camera. And you can see what the blending percentage is of these different cameras. And I can turn this one down, and it goes all to the top camera. So this is controlled in this little script here, the mixing camera blend script that sets the initial weight, the axis that I'm going to track here. And what I'm going to do here is my character is going to run forward. And as I run forward, it adjusts the weights of the different cameras. And as I run back, it sets them. So it's basically looking at my position in the Z-axis here and deciding what weight to assign those cameras. And it blends between them. I think there's a little setting here somewhere. No, there isn't. That's just the feedback that you get. But anyway, that's the mixing camera. Let's see, blend list, ease in and out. Mixing assigns different weights that you control for scripting. And the Clearshot here is a really cool one. This one selects the camera that has the best view. And all I did was put a gun on the camera. So this becomes kind of an automatic gun turret that targets the player. And so my little player is stuck here behind these little walls. And if I move behind the wall, it finds a camera that has the best shot at the player. And so not only does the camera track, but the little gun turret that I've got in here also tracks. And of course, you don't have to actually put a camera in it. You can just have the gun and it's going to be an automatically targeting gun. So, and Clearshot has the different cameras. I've got 8 cameras placed front, back, left, right, and then off on the diagonals for the 8 different cameras that I've got around. And the Clearshot just selects the camera that has the best view of the neck of my character here that I want to set it. And there are various settings for how they blend, how quickly they blend, and other stuff like that. That's the Clearshot. Very cool. State-driven is pretty cool as well. Don't save. So here I've got a little character, and this character has an animator that has basically 2 animations. It's got a blend tree for locomotion that is a walk, idle, jog. So that's kind of the slow movement. And then it's got a sprint that is the running motion. And my state-driven camera just says that whenever it's in the locomotion state, it's going to use the free look, and whenever it's in the sprint state, it's going to use the free look sprint camera. I have these 2 different cameras, the free look and the free look sprint. And this little gizmo up here showed debug text during play. This is going to give me some feedback about which cameras are active and what percentage of them are being used. And so without having to do anything more than plug these different things in here, and I need the animated target here because I need the animator that is controlling it. So when I'm just walking around here, I'm in a free look camera that looks like this. But if I sprint, which I believe is the space key, it drops back to, oops, I don't want to run off the edge of the world. It drops back to a further back camera, lower angle, with a lot of noise in it. This is the noise module in action here, showing the use of a particular kind of noise. And so that's really cool. I've got another one where I animate the dude and different cameras trigger when he does flips and other stuff. Maybe I'll post that, I don't know. But it's pretty simple. And if you have some complicated animator with like a dozen different states, you could have a dozen different cameras, each for a different state that the player was in. And it's really simple to do. So very cool. An example with two states, the character has locomotion and sprint. Both cameras are free look with a slower paced locomotion further away, narrower field of view. So I'm changing the field of view of the camera as we move to the different cameras, and I'm adding this noise, handheld wide angle strong with amplitude and frequency gains. So lots of fiddling to get things to work. Here are the heights and radii of the different free look cameras. Two other worthwhile tricks are the group composer, and the group composer will keep a collection of objects in view, and it does this by a combination of adjusting the field of view of the camera or zooming the camera in and out as necessary. And with these options, you can set the minimum and maximum field of view that you allow. And you can also adjust whether it only adjusts the field of view or whether it allows it to dolly the camera backwards and forwards. And there are various different settings here. Again, lots and lots of options. And so let's see, where am I? So I kind of combined that, whoops, where am I? I'm not, those are demo scenes that come with the asset. So here is the group. I have a group of ships here. Let me get back into the standard scene view here. So I've got these little ships, little cubes that are themselves going to move around in the world, and I'll show you how they move around in a second. And my camera, the camera that I'm using here is a tracked dolly camera. This is one of the choices for the body of a camera. And the tracked dolly, which is the other thing that I wanted to talk about here, the tracked dolly. But the tracked dolly is where's the track? Where's the track? Oh, camera path. So here's the track. This is the dolly track that the camera is constrained to move on. The camera is going to stay on this path, although with the zoom feature of the group composer, it will sometimes move off the track as it has to move in closer. And this camera path is kind of a cool thing. It's the Cinemachine path. It has various different positions on the path, and it makes a spline curve in amongst them. You have a lot of control over the position and tangent and how much roll you want. So this is not just a waypoint, but it's also a waypoint and orientation. So things roll and turn and move on them. And I've actually used that tool to make paths for the ships to roll around on. So the ships are following Cinemachine paths. They don't have cameras on them, but these ships are following these Cinemachine dolly carts. So all very cool. And we can have these things move at particular speeds, and they start at particular positions on the path and follow them around. So the target group, we have to make a target group, and this is a game object. Where it is doesn't matter because it's going to adjust its own position, but we have to load in the different things that we want to be targets. Each of these things have different weights, so it can focus more on one object than another. We have different ways of assigning the position, the group center or the group average, and other stuff that we can set. But the bottom line here is it's going to keep the objects all in view, no matter how far apart they move. And I believe in this case, the camera on the dolly cart is not moving along the cart. What it's doing is it's finding the best position on the dolly track to be closest to the target, which is this cinema target group. That's what our camera is looking at. And so this camera finds the position on the dolly on its track to be closest to its target. And you can also fiddle with it and make it furthest or ahead or behind. There are lots of different things you can do with this. And the last scene I'll show here is kind of the same, except in this case, I've sort of put a motor on the camera's cart here. In this case, on the dolly cart, I'm specifying that the camera has a speed and the initial position. And so now the camera is just going to drive around the track at a fixed speed of 100 units per whatever. And you can see the position there changing as it moves along, all the while keeping things in view by adjusting the, let's see. It's adjusting the field of view of the camera. You can see the field of view changing to keep things in. It's apparently staying scrupulously on the track, although that's a setting that you can change where it will actually zoom in off the track if you have it set to do that. So all very, very cool. And of course, this only scratches the surface of what you can do with Cinemachine. It's actually built to work with the timeline. So things like the timeline can be set up to make really fancy things. And oops, that's not what I wanted. That's not what I wanted. Project is open. I want this project. It's already open. That's not what I wanted. This one? This one. Where are we? Scenes. Main. So this is an example of using the Cinemachine cameras with a timeline, and it's controlling the different cameras and moving them around, doing these different blends between different cameras that you have set up. And the timeline is also controlling all the other stuff that's going on in here, including the launch of the rockets. There's that noise module with this particular virtual camera, and this shows the rocket launching, and ultimately it gets into space. And this is all done with timeline, and it's pretty cool. And it's turning on and off objects, but basically this just shows that the timeline here. Where's the timeline? We're in the orbit timeline. I don't know how to show it. I'm sorry, I can't show it here. But anyway, timeline's a whole another TMO of its own. And Cinemachine works well with timeline. So I'll stop there and stop sharing and entertain any questions that anyone might have about Cinemachine, which is very cool. Let's see. Yay, levels fly through like Final Fantasy. Super cool for doing level intros. Absolutely. Oh, I don't know. You're talking about something else. All right. So any questions, comments, suggestions? I did not make that rocket launch. That was somebody else's. Well, and if there are no other questions, bye-bye.
Thank you. Have a good day.
You too.